We're going to go through an example of thermal conductivity of a material. And so what we have here is we have a heat box that's powered by a 60-watt light bulb. And so our problem is we put some unknown insulation material on top of this box, and we want to see how conductive it is to heat, or how its ability to allow heat to pass through it. And so theoretically, a good insulation material would not allow heat to pass through it. And so we have some knowns here. First of all, we know the area of our box. And so that is this area made up by the blue rectangular shape. We know the area is 0.5 meters squared. We know the change in temperature. And so we have a temperature probe on the inside of this box, and we have a temperature probe on top of the insulation material outside of this box. And so the difference, the inside to the outside, is 30 degrees Celsius. So it's 30 degrees Celsius warmer in the box than it is on top of the insulation material. We also know that our energy source here, the light bulb, has 30 watts of power. And we know the thickness of that insulation material that would be theoretically put on top of this box is 0.15 meters. And so again, we're going to try to figure out the thermal conductivity of that insulation material that we're putting on it. So if we look at our equations here, we can manipulate this equation right here for the rate of heat transfer to solve for thermal conductivity. And so we'll do that by writing that formula first. Thermal conductivity is equal to the power times the thickness of the material over the area, the area times the change in temperature. Okay, so we plug in our variables. The power is 60. The thickness of the material is 0.15. Over the area, 0.5, times the change in temperature, which is 30. Substitute or solve the top part, we get 60 times 0.15 is 9. Solve for the bottom part, we get 0.5 times 30 is 15. So our thermal conductivity is equal to 0.6. And the unit is joules. Second. Meters. Degrees Celsius. So the lower this number, the less that material is conductive to thermal energy, and the better insulation material it is.